We're going to use a nice software tool from the folks at PHET to explore inductance. And what I have here is two circuits. The circuit on the left is just a pure resistive circuit. It's got a battery, a resistance, and a switch, and that's it. The battery is 2 volts. The resistance is 1 ohm. And so we would expect a current to flow of 2 volts divided by 1 ohm, or 2 amps. So let's close the contact, and we see the current flowing in the circuit here. Each of these little balls represents about a coulomb of charge. And so each one of those little balls is passing past, or there's actually 2 of them passing past a point in the circuit every second, which represents 2 amps. Now let's measure that and make sure we're right. I'm going to take this little non-contact ammeter, and sure enough we have 2 amps. The circuit on the right is identical to the circuit on the left, except it contains a component called an inductor. And in its simplest form, an inductor is just a coil of wire. And the more coils you have, the more inductance you get. You can also change the properties of an inductor by changing the material in the center of the inductor, the core, what we call the core. Or you can make an inductor physically bigger to get more inductance. But a perfect inductor has no resistance. So for all practical purposes, this circuit should be identical to the one on the left, because we have a 1 ohm resistor, a 2 volt battery, and an inductor with no resistance. So you'd expect the current to do exactly what it did in the circuit on the left. So let's try that. Let's close the switch and see what happens. And this is really odd, isn't it? Because the current did not come on instantly. In fact, it looks like it's building up. And let's look at what's happening to the current here. It's at 1.5 amps and climbing. So this is really odd behavior for a circuit. The current didn't come up to the value that we expected, but it's converging, or it's approaching 2 amps, because as you look, you see that the current is changing less and less rapidly as we get closer to 2 amps. So it's approaching 2 amps. So the resistor is doing something in the circuit. It's limiting the current to 2 amps. But apparently the inductor is keeping the circuit from instantaneously getting to 2 amps. And that's one of the properties of inductors. Inductors prevent instantaneous changes in current in a circuit. They do this by creating a magnetic field that stores energy. And the magnetic field moves in a way that prevents the current from changing instantly. It sort of opposes the current that's causing the magnetic field in the first place. But the net result is we store energy in this magnetic field, and when the magnetic field is building, it's pushing against the current, and when it's collapsing, it's aiding the current, causing the current to continue to flow in the same direction it was going before. So one thing I want you to look at is, I'm going to stop this current and we're going to look at it again, and we know it got to 2 amps there. But notice, what does this remind you of as this current increases? And in my mind, it reminds me of a train. So a train starts off at rest, and it slowly builds up speed until it gets to some maximum value. And that's what this circuit sort of reminds me of, a train. Trains do that because they have a property. They have mass, which means they have inertia. And so it takes a while for a train to get up to speed. And the reason it takes time for the train to get up to a certain speed is it's actually storing energy. Trains store what we refer to as kinetic energy. And so when a train starts out, it has to push very hard. So from physics, you should know that there are 2 types of energy: potential energy and kinetic energy. Inductors store kinetic energy. or we can look at them as storing kinetic energy. They're storing energy due to motion, in this case, motion of electrons. Capacitors store potential energy. They store energy in the form of an electric field, energy due to position. So in the case of a capacitor, we push electrons onto one plate and we pull electrons from the other plate. There's a force between the plates, and the charge on the plates exerts a force. In the case of an inductor, it's storing kinetic energy, and the property of kinetic energy is that it's energy due to motion. So we can look at these two devices that way, one potential and one kinetic. Because inductors have this property of preventing instantaneous changes in current, then that means we can do some interesting things with inductors. For one thing, let's see what happens when we try to stop this current from flowing. So we already know that we have 2 amps of current flowing. The resistance is limiting the current to 2 amps. The inductor, remember, doesn't have any resistance, so it's not contributing to the resistance of the circuit. It's just the resistor that's contributing to the resistance. So we have 2 volts divided by 1 ohm is 2 amps. Now we're going to monitor the voltage here across the resistor. And we're going to do something interesting. We're going to change the resistance. The simulator allows us to change this resistance. Right now it's 1 ohm, and we're going to change it to 10 ohms. So I'm going to go over here and change this to 10, and before I actually change it, commit that resistance, let's think about what this means might happen. If the current is going to continue to be 2 amps after we change this resistance, that means we will have 2 amps through that resistance for a short period of time. Now let's look and see if that actually happens. Look at the voltmeter when I commit this change in resistance. And if you noticed, it started out around 20 volts. It was so quick it came down to 17 pretty fast. But look what happened. The voltage started out at a high voltage, around 20 volts, came down rapidly to 2 volts, and now our current is 0.2 amps, which is what we would expect if we had a 10 ohm resistor and a 2 volt battery. 10 volts divided by 10 ohms is 0.2. So Ohm's law is holding now, but for a brief period of time we had a 2 volt battery with the highest voltage that we had in the circuit, but we were able to pull 20 volts from that circuit for a short period of time. And that's the interesting property of inductors.